So now we are in lesson 4.6. It's about the implicit differentiation and related rates. It's a short lesson. The first part is about how to differentiate a term uy with respect to a different variable x. So I can give you an expression. In this expression, you have, for example, y and x. You need to do the differentiated with respect to x, to t. So how we gonna do it? We need to use the chain rule. We already saw it in the preceding lesson. For example, if I have the expression uy, I want to do duy over dx, so I need to do the chain rule. So I need to do the derivative of u with respect to y times dy over dx. So it means it's u prime y times dy over dx. To understand more what I'm saying here, let's do an example. Let's say I have this equation and I need to differentiate this equation with respect to x. So I have x3 plus y3 minus 9xy is equal to 0. So d over dx of the expression is equal to d over dx of 0. First, the derivative of 0 is 0. And then it means I need to do the derivative of each term. The derivative of x3 with respect to x, d of y3 with respect to dx, minus 9 dxy over dx. Now, the derivative of x3 with respect to x, I can do it easily because I have the same variable. This is x3 and x, so it's going to be 3x squared. I cannot do the derivative of y with respect to the x. It's not the same variable. So I need to use the chain rule. So I need to do the derivative as I'm decomposing. It's dy3 over dy times dy over dx. And then here, the derivative of x times y here, I'm doing u times v, guys. And you know that the formula of u times v, it's u prime v plus v prime u. So it means I need to do the derivative of x with respect to x times y plus the derivative of y with respect to x times x. Then I will continue here, it's 3x squared. The derivative of y3 with respect to y, it's 3y squared times dy over dx minus 9. And now here I have the derivative of x with respect to x, it's 1 times y plus dy over dx chain rule. It's dy over dy times dy over dx times x. Dy over dy, it's 1. So it means here I will have dy over dx times x. Then you will develop the 9. So it's going to be minus 9y minus 9x dy over dx. So I will have 3x squared plus 3y squared dy over dx minus 9y minus 9x dy over dx equal to 0. Now what I really need to focus on, I need to find dy over dx, the derivative with respect to x. This is what was the question about. So I factorize here by dy over dx, I will have 3y squared minus 9x. And then I take the other two terms to the other side, and then I will have it equal to 9y minus 3x squared, and then I will do over. So what's going to be the derivative of this expression with respect to x? It's 9y minus 3x squared over 3y squared minus 9x. Now I can ask you another question, in the same part. Find the equation of the tangent and the point 24. I can ask you the equation of the tangent or the normal. It's if you know how to do the tangent, you can do the normal because you know that the equation of the tangent is y equal m. I wrote m because normally we know it from the preceding chapter. It's f prime preceding chapter f prime of x of the point. But here the expression is in terms of x and y. So I can write it dy over dx in terms of xy. And we know that the equation of the normal will be minus 1 over f prime of x of the point. So once I got the slope of the normal will be the negative reciprocal. So first step, I need to find the slope. So it's dy over dx. And already it was done here in this part. So this is dy over dx. So all what we need to do is to replace x and y by its value. So I will replace x by 2 and y by 4. So this is the normal, this is the slope of the tangent. What's going to be if I want to do the slope of the normal? It will be minus 5 over 4 if I need to do it. And then all what do we need to do is to replace. Y is equal 4 over 5, x minus 2 plus 4. You develop, and this is the equation of the tangent. If I need to find the equation of the normal, I will replace 4 over 5 by minus 5 over 4, and then I will distribute again, and I will get the answer. Another part in this lesson, how do we use the derivative with respect to a variable in the real life application. So I have this exercise. A 25-meter long industrial ladder is leaning against a wall on a building site. So this is the ladder, I can see it here. The bottom of the ladder starts to slip along the floor at a rate of zero point 0.2 meter per second minus 1. So it's slipping like this. So who's changing here now? This one represents the dx over dt. So this is dx over dt. It's zero point 0.2. Determine how fast the top of the ladder is moving down. So the top of the ladder, so it's rated to y. So I need to find dy over dt. If at the instant when is it's 20 meter above, so for y equal to 20 meters. So first of all, when you have a real life exercise, you need to think about how do we find a relation between x and y. And then after doing that, you do the derivative with respect to the time. If you look here, you have a right triangle. And you know that in a right triangle, I can use Pythagoras. So I have x squared plus y squared equal to 25 squared. X squared plus y squared equal to 625. I do the derivative with respect to the time. So derivative of x squared plus y squared with respect to the time is equal to the derivative of 625. This is 0. And then I do the derivative of the other two variables. And I need to use also the chain rule. So I will have here dx squared over dx times dx over dt plus dy squared over dy times dy over dt is equal to 0. It will be 2x times dx over dt plus 2y times dy over dt is equal to 0. Now I need to focus here on this equation. I have one unknown that I need to find, that's it. And all the other values should be given. This one is given, it was 0 0.2. And they gave me at the moment y equal to 20. So y is given. I need to find x. So I'll use Pythagoras to find x. So I'll use x squared plus y squared is equal to 25 squared. And then when I replace y by 20, I will get x 15. Now x is given. The x over dt is given. Y is given. All what do we need to do is to replace. So I will replace by the values. I will have 2 times 15 times 0 0.2 plus 2 times 20 times dy over dt, and then I solve for dy over dt, and I will get the answer minus 0.15 meter per second minus 1. What does it mean, this answer? It means that the ladder is moving down at a rate 0.15 meter per second minus 1. Sure, we will do more application in the class. That's it, guys. Repeat the video if you didn't get it, and see you in the next video.